My name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for SAT. We have been solving SAT math problems out of this book here, the official SAT study guide. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 669. Page 669. Today is our lesson number 72. Let's take a look at it. Number 6 is what we're going to do. Very first problem on the page. And they give us a little graph here. I'm going to reproduce it here. -2, -1, and it goes up to 2 again at 1, and it becomes flat again. And the question is, if the value of g of k equals 1, then which of the following is a possible value of k? What does it mean in English language? What are they trying to say here? In English language, what this means is, this is read as g of k. This is how we read it. What does it mean in English language? It simply means, what they're telling us here is this. If the value of the function is 1, then what could be a possible value of x, or k in this case they're calling it. They want to be cute, so let them be cute. They don't want to call it x, they want to call it k. So here's some variable k which is being measured along x-axis. They're measuring some variable k, some variable that they're calling k along x-axis. And the question is, at what value of k is the value of this function equals to 1? Well, the value of the function is equal to 1 when x is equal to -1, right here. This is 1 right here. The value of the function is also 1 when x equals 0, or k equals 0 if you like. Value of the function is 1 for any value between -1 and 0. The value of this function is 1 for any value of x between -1 and 0. Now notice here I put down x. This is between, by the way. Here I put down x. Whether it's x or whether it's k, it doesn't matter. As I said, they're calling this independent variable k, which is fine. So the value of, one more time, the value of this function is 1, as you can see, is 1 between -1 when x is equal to -1 all the way to when x is equal to 0. And then the value of the function increases, and it goes up and up and up and up and up and reaches the value of 2. The value of the function becomes 2 when x is +1. And then after that, the value of the function is 2 regardless of what the value of the x is. But we're not interested in any of that. Only thing that interests us is this region, right here. This is the only region that we're interested in. So they're asking us for what one possible value of x is the value of this function equal to 1. The answer is any value between -1 and 0. Do you see anything there that falls between -1 and 0? -1.5, -1.5 does not fall between -1 and 0. Nor does 1, nor does 1.5, nor does 2. The answer is B. The answer is B. And the B says -0.5, which is going to be right here. -0.5, right here. There you go. At that value also, when x is equal to -0.5, the value of the function is 1. The value of the function is 1 throughout that region from -1 all the way to 0. That's it. Number 7. Number 7. So if you want to show it here, this is how we'll write it. We'll say that the value of the function is negative, value of the function is 1 when x is equal to -1. The value of the function is 1 when x is equal to 0. And the value of the function is also 1 when x equals -1/2. Or in our case, they're calling it, as I said already, they're calling it the independent variable k, which is where the confusing part comes in. And why are they doing it? I already gave you the reason for it, because they want to be cute. That's it. Number 7. By changing the name, by instead of calling it x, all of a sudden they introduce this new name for the independent variable. Instead of calling it, because maybe you don't want to call it x. For example, if along the x-axis I'm measuring the age, if I'm measuring age along the x-axis, maybe I want to call this variable a. I don't want to call it x. I want to call this variable a. If I'm measuring the speed along the x-axis, I don't want to call it x. I want to call it s. It's just a name that you assign to the independent variable. They call it k. I don't know what the hell they're measuring over there, but whatever it is, they're calling it k. That's all. Number 7. If a, b, and c are different positive integers, alright, so they are all different, which is very important, and they are all positive integers, which is also a very important thing to keep in mind. And then we are told that 2 raised to a times 2 raised to b times 2 raised to c equals 64. And the question is, what's the value of 2 raised to a plus 2 raised to b plus 2 raised to c? So somehow we have to figure out what this a, b, and c are going to turn out to be. Let's find out, shall we? Let's find out. First thing we need to do is, because these are all bases of 2, if we had something written here in the base of 2, that will make our life easier, because then we can compare the exponents. How can we write 64 as 2 raised to some power? 2 raised to 1, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, and 32 times 2 is 64. So how many do you see here? I see 6 of them, which means this can be written as 2 raised to 6. That tells us, now listen, that tells us, this implies that because it's 2 raised to 6, which means, how do you, when you have a number being multiplied which is with the same base, this can be written as 2 raised to a plus b plus c, which we just found out is same as 2 raised to 6. That tells us that the sum of these three numbers, a plus b plus c, must be 6. Now, because of the fact that they are positive and they all have to be different, there are very limited scenarios that we can have here, which is simply 1 plus 2 plus 3. That's it. 1 plus 2 plus 3 will add up to 6. Now, we're not claiming that a is equal to 1 and b is equal to 2 and c is equal to 3. We're not claiming that. There is no way we can tell that for sure. It doesn't matter. The point is, one of them is 1, the other one is 2, the other one and the third one is 3. That's all it is. So now we can figure out the value that they're looking for. What they're asking us is, how much is the value of a raised to 2, 2 raised to a, plus 2 raised to b, plus 2 raised to c. We can figure it out. Just plug in 1, 2 and 3, that's all. So let's do it. Let's plug in 1, 2 and 3. 2 raised to 1, plus 2 raised to 2, plus 2 raised to 3 will give us the answer that we're looking for. 2 raised to 1 is 2, 2 raised to 2 is 4, 2 raised to 3 is 8, 6 plus 8 is 14. Voila. 14 is our answer. Answer is A. Answer is A. Let's go to the next one, number 8. In number 8, we are told that in the xy plane, the center of the circle has a coordinate of 3 and -7. Alright. So 3 and -7. 1, 2, 3 and -7. 1, 2, 3, 4, 5, 6, 7. Right here is the center. Let's call it C. So far so good. If one endpoint of a diameter of the circle is -2 and -7, -2 and -7, 1, 2, and negative 7 right here. So this is one end of the diameter. The question is, if one end of the diameter of the circle is negative 2 and negative 7, what are the coordinates of the other end point of the diameter? Well, very simple. Because of the fact that they're telling us, that when we join this point to center, it is a part of the diameter. That means this, what we're looking at here, is half the diameter. Here is the other half. And wherever it ends, the length of this part has to be the same as that one, obviously, because the C is the center, which means this is the radius. And how much is it? It goes all the way up to 3, and it starts at negative 2. From negative 2 to 3, is 5, which means the radius of the circle is 5, which means we have to go 5 units here. So we start at 3, we go 5 units, 1, 2, 3, 4, 5. We're going to end up at 8. 4, 5, 6, 7, and 8, you see? Here's the other center. Not the other center, rather. Here's the other end of the diameter. Let's call it A and B. And this one has the coordinates of negative 7 and a positive 8. Negative 7 and a positive 8. Negative 7 is the coordinate of the y. Negative 7 is the y coordinate. Negative 7, as you can see. Positive 8 is the x coordinate. Sometimes I wonder, what the hell is the matter with me? I wonder if you wonder the same thing. But because I do wonder, what the hell is the matter with me? Whether or not you wonder about the same thing, I do not know. Anyway, this is our circle. And it looks I shouldn't do that because the diameter is 5, so we have to go all the way up to 5. It cannot go, it's going to go 1, 2, 3, 4, 5. It's going to go somewhere here. It's going to make a circle. Anyway, the answer is 8 and negative 7. 8 and negative 7. Number 9. A regulation for riding a certain amusement park ride requires that the child be between 30 inches and 50 inches tall. Those are the regulations. If the child's height is below 30 inches, that child is apparently too young for the ride. And if the child's height happens to be more than 50 inches, that child is apparently too old for the ride. So here is this. The height, we are told, height of the child has to be greater than or equal to 30 and has to be less than or equal to 50. If the child's height happens to be 30 inches exactly, which is fine. 30 inches is the cutoff. If you're 30 inches, then you're fine, but if it's below 30, we won't take you. So they make you stand up against a measuring tape, and if you're 30 or above, you can get on the ride, and if you're 50 or above, get the hell out of here. Do you understand? So how do we write this? This implies that the height of the child, whatever it is, has to equal 40 and plus or minus 10. Plus or minus 10. It could be 40 all the way up to plus 10, it will go all the way up to 50, or it could be 40 and minus 10. This is the other end of the extreme. 40 minus 10 will be 30. That's one way of writing it. Another way of writing another way of conveying the same concept is like this. The height that we have, the height of the child, minus the 40 inches, this difference, listen very carefully. Listen very carefully. Let's pretend that we have a child whose height is 48 inches. If it's 48 inches, then 48 minus 40 will be 8. On the other hand, if the child's height happens to be 38, 38 minus 40 is negative 2. But whatever this difference is, whatever the difference is between the child's actual height and the midpoint. 40 is the midpoint, you see? It's 40 plus or minus 10, you see? 40 inches, right in the smack in the middle. You could be 10 less than that, you could be 10 more than that. You're right. If you happen to be 40, you're right in the middle. That difference between the midpoint, that's what the height is here, whatever the child's height is, minus the midpoint, which is the 40, which is the mark of 40, the actual height of the child and the midpoint, which is 40, that difference the absolute value of it has to be equal to 10. Has to be, or rather, has to be less than 10. Well, if it's less than 10, then I don't think we are allowed to be 30 inches exactly. Because all the answer choices I just noticed do not have equal sign. They are all less than 10. Less than, they do not have equal sign, which means I misread it. A regulation for riding a certain amusement park ride requires that the child be between 30 inches and 50 inches tall. I was wrong. It has to be between 30 and 50, not from 30 to 50. I misread it. The height does not need to be, the height does not say it has to be from 30 to 50. It has to be between, which means it has to be something more than 30 and it cannot be 50. It has to be less than 50. This was wrong. So this part still holds there. The difference has to be, the height has to be 40 plus or minus 10. I'm going to leave it there even though technically it's not true there. And therefore the absolute value between the actual height of the child minus the midpoint has to be less than 10. As you can see here, if the actual height happens to be 48, if the child happens to be 48 inches tall, then 48 minus 40, which is going to be 8, which is less than 10. The absolute value of 8 is less than 10. Similarly, if the child's height happens to be 38 inches, 38 minus 40 would be negative 2. That child also qualifies because the absolute value of that thing is less than 10. So as long as the absolute value of the actual height of the child minus the midpoint of the range, which is 40, if that difference is less than 10, we are okay. It doesn't matter whether it's positive or negative, obviously, because you could be below the midpoint 10 up to 10 units, or you could be above the midpoint up to 10 units. And that's how we show it. This is it. This is our answer. And that answer would be D. That answer is D. Let's do the very last one, number 10. Number 10. A right circular cylinder with the radius 5 and the height 4 has a volume of V. Alright, so here's a right circular cylinder. How do you find a volume of a cylinder? Now before we can answer that question, we have to ask ourselves, what does it mean, the concept of volume? What does volume measure? When we talk about volume of anything, what does it measure? Volume tells us the space that is encompassed by a certain container. How much stuff you can put in it, that's what it measures. How much stuff I can put in it, okay? Let's keep listening. How much stuff you can put in the cylinder, that's what this is. How much stuff you can put in the cylinder depends on two things. It depends on how wide open it is in the top, the volume of a cylinder, which is same as how much stuff you can put in the cylinder, depends on two things. One is how wide open it is on the top, and the second thing it depends on is how deep it is. Ask yourself, how do we measure how wide open is the cylinder on the top? How wide open the cylinder is on the top, that is same as saying, what is the area of this circle, this circular opening that we see there, what is the area of that circle? The bigger the area, the more wide open it is. That's what it is. So this answer of this question is the area of the circle, which is simply pi r squared. Second thing that we need, the second dimensions that we need to concern ourselves with is how deep is it? Well, how deep it is the height. Just like when we talk about the area of a rectangle, we need to know what the length is and we need to know what the width is. Once we know the length and the width, we just multiply the two things and we get the area. That's all. This is it. Once we know how wide open it is, we multiply it by how deep it is. And that's it, that's our volume. That's the volume of the cylinder. It always amazes me to see kids going around memorizing the formula for the volume. Or even worse, during the exam, they will go to the front of the exam because that's where they give you the formulas, and they will look for the formula for the volume. That's a very bad sign. If any students during the exam has to go in the front of the book to see what the formulas are, that's not a good sign. These are such basic concepts that you should know. You should know them by heart. You should have them at your fingertips. You should know like that, just like that. These are very basic concepts. They should not even give these formulas in the beginning of the exam. I do not know why they do that. They give you, if you turn to page 368, if you turn to page 638, or perhaps even the beginning of this section. I think they do it in the beginning of every section. You don't have to go all the way up to 638. If you go to page number 667, on page 667 where the section starts, they give you the formula. They give you the formula for the area of the circle. They give you the formula for circumference of the circle. They even give you the formula for how to figure out the area of a rectangle, for crying out loud. They give you the formula for area of the triangles, and the volume of a rectangular box, and the volume of a cylinder, and the Pythagorean theorem. None of these things you should have to look up. And even the spatial right angles that you see there, even those things you should know them by heart. These are very basic elementary concepts. Anyway, enough said. So this is the volume. And therefore, the volume of this guy that is given to us is, we are told that the radius is 5. Radius is 5 and the height is 4. So let's find out. So the volume is pi r squared times h. We are told that the radius is 5 and the height is 4. 25, 5 squared is 25 times 4 is going to be 100 pi. And then what happens? In terms of V, what is the volume of a right circular cylinder with a radius 5 and a height h? Height 8, oh, for crying out loud. If the height is 8 instead of 4, then it's twice as deep. And if it's twice as deep, you can put twice as much stuff in it. That's all. The volume of the new cylinder is twice as much as the volume of the old cylinder. Because you see, let's call this one V1 for the old one. And the other one is going to be, let's call it V2, pi r squared times h. They're not changing the radius. The radius is still the same. It's the same radius 5 squared, which means it's same wide open. It is widely open. It is on the top as the first one, except instead of 4, we have an 8. That's all. So if it's 8, it's same as pi times 5 squared times 4 times 2. This was, we just found out, is 100. It's 100 pi times 2. So the new volume is twice as much as the old volume. Therefore, this guy V2 is simply 2 times V1. But they don't call it V1, they just call it V. That's all. So it's 2 times V. By the way, if you have watched my previous videos, as I explained to you a couple of times before, I have a tremendous amount of difficulty pronouncing this letter. So just when I say V, that's what I'm trying to say here. I'm trying to say this letter. This letter and this letter, in my native language, we only have one sound for them, for both of them, and therefore I cannot pronounce them the way they're supposed to be pronounced in English language. So when I say V, that's what that is. Do you understand? It's just something I have learned to live with. People ask me what I drive, and I tell them I drive Volvo, and they look at me and they say to me, what the hell is a Volvo? Such is life. I will see you tomorrow, okay? Bye now.